The first question.
I'm not doing it until I get to the. You can bring the treasure. Yeah, good. How's that?
Wilson. Okay, I suppose we should get started. If anybody's interested in Select Sire's premier internship opportunities, I'll send this out, but you can take a picture of it to get a jump on it. They have a communications intern. Yes. Yeah. Take a picture of it on the way out. We'll also send it to you by email as soon as I get it scanned. So, okay, so cell phones away. Your first question, if you haven't turned one in, is due today. Next pro tip coming out, form a study group. Last year, as the entire class participated together, working together, studying together is a good way to look at different perspectives, find different ways to remember things. The cross-fertilization that happens in a study group is a real good thing. I know some of the ones I had in college were real, nothing else, they were a lot of fun. So announcements, we got a review sessions on Monday. Lab, we're going to be roaming in the room tomorrow. So we're going to do a room and dump. So we're going to take all the contents out of a cow's rumen, put it in a garbage can, take a look around. That means your shirt and possibly your pants are certainly going to smell bad, but rumen fluid stains and it does not come out, not without effort. So bring a shirt that you don't like or don't have a real affinity for. So clothes that you don't care about. When we did this in grad school, we had everybody had a set of clothes that was dedicated to the task. If we have time, Professor Hayes' class wants to participate. If we have time, we'll do some more feed ID. And then for scheduling dry matter testing, I have to emphasize, follow the directions. You've got a list of things I want you to do. Do what's on there, not what, don't look at what I'm doing on the thing because I do things a little bit differently for different reasons. So 150, 100 to 150 grams, an hour should get it done. If you put in 500 and only do it for an hour, things are going to go wrong. So I handed out the directions. The directions are up on Brightspace, and there's also a copy of directions at the station there. So follow the directions. They're there for a reason, and I want you to do it that way. Making up lab 1. Who wants to do that? Anybody else? So if you two can get together and figure out a time, I only want to do makeups once. Who wants to do makeup on lab 2? We got one? Okay, so you need to find a time. Anybody doing a makeup on lab 3? Anybody else? So schedule. So this is what I can do next week. When do you want to do 2? So it should take about lab 3. When do you want to make up at the dairy? Okay, there's a schedule up here. Which time fits for you? Where there's no X's, I can work. Tuesday when? In your end of the day. Lab 3 makeup. Lab 2 makeup. We got 3 of you in here, 4 of you on that. When do you guys want to do that? I can also come in way early and way late if you want to, but those are the, 8 to 6 hours. Suggestions. 1, 2, no, Rivera's not here. 1, 2, 3. Do you want it or not?
I think you need to say that.
Lab 1. You do Tuesday at 8 a.m.? Okay. Other times? No on Friday. Wednesday, I'm guessing you've got perhaps 160. Wednesday, 9 to 11. When? 9 to 11. Wednesdays. Can do that? Next Wednesday. We'll put it up as we go forward. Okay. So they'll be up at the dairy unless we talk about something different. Okay, so what do we have? So next up for dry matters. Giving you. Okay, you're all set? Okay. As we move forward. Questions from the class. So we've scheduled makeup times. What are assays and assets? What's the difference? Assay is a chemical process we do in the lab to determine the amount of something. Sorry, my Jersey accent is a little weird. I'm a West Jersey, Eastern Pennsylvania accent. We say water funny. We swallow the R, water. So, assets are the things that are of value that you have in a business. What is a nutrient? Anything required by the cow or anybody to stay alive. So it's something usually of organic compound, but the minerals don't fall into that category. Everything else is organic. Why do we calculate dry matter percent? How often do farms analyze their dry matter percent? Why do we calculate? We're trying to be precise. When you're feeding a dairy cow, you're taking nutrition to a level that's way above everybody else. Most species of livestock, you have to feed them a carrier that's got the protein grain or protein, minerals, and vitamins, and then you feed them something else to fill them up. We're got limited storage space, limited dry matter intake, and we got to fit all the nutrients in that package. So we need to make sure everything's where it's supposed to be. Measuring the dry matter, or why do we calculate that, is making sure that we're feeding nutrients to the cow, not water. Water's not going to help us out. So trying to get that right, it balances the rumen, keeps the animal healthy. All of those things we'll get to a little bit more, but if you're going to run a good, effective dairy program with their lactating cows, you need to measure your dry matters. How often do farms do it? There are some places that do it every day. There are other places that never do it at all. But to me, it's essential. If you're going to do a high level program, you're going to need to do it. What are some of the most impactful human, I forgot the word, diseases, impactful diseases humans can pass on to cows and vice versa? The one of big concern right now is bird flu. Seems to be pretty nasty, although it seems to be petering out in the cows. Pretty much all the diseases going back and forth are problematic. Tuberculosis is a bad one. That one moves back and forth between our cattle and us, which is why we have so many rules and regulations in the pasteurized milk ordinance, going back and forth on that. Pink eye probably can move back and forth. Certainly ringworm can, but TB in the short run's the worst one. There are concerns about bovine spongiform encephalitis. Everybody knows what that one is. Mad cow disease. We go to great lengths to make sure that no animal with mad cow disease enters the food chain. It's never been linked back and forth, but we're not going to take that chance. Holes in your brain, I think, would bother me. That's what happens with that. How do we find the perfect feed for a cow? Well, it depends on what she's doing. So again, we're defining the feeds, we're defining the animal, and then in that interaction is where we find our perfect food. So there are a lot of opinions on that. We'll get to some of those at the end of the semester. Any other questions? Okay, it's team quiz time. Put your notes away. I want you to try to do this without the help of your notes, but you can have a neighbor, phone a friend. So everybody's to turn one of these in, but you can work together with the same answer. So take some time, given what we learned last time, and you fill this out. Highly probable you'll see something similar to this on the exam.
Yeah, because remember chicken don't. It's amazing, but it's right. Oh, yeah, question. No, and the affirmation is VFA. What's that? Wait, no, what's water? There. But there's still water. There's water. Yeah, the affirmation also works. Like bonded to the. They're taking. I didn't need to work this way. What are you doing? Electrolyte. She said it.
Yeah.
So that metabolism is like the final digestion. And I don't know if it's like the reticulum like stimulates the rumen to like fertility, or if it's the rumen stimulates fertility. Well, I think for reticulum, it's done. Yeah, it's like it's stored fat or something. Like that's the main. I'm worried about this. I think it's the main step. Mm. How are we supposed to do this? Increased surface area structure is the structure of P. And that's in like P's, right? I don't know, cause the which one is the part that E's? That's the like the honeycomb. Because that's what is this very. Which I feel like my brain's would be it's another part to eat, but I don't remember. I just what's it called? So that because it was like the allowance is the like yeah, like the direction.
What else? Yeah.
And then this is like the. It's like that looks right to me. Like. Okay. I don't. This looks the same. Wait, I have to think of what that other one was. This is stability and purpose. My memory is starting to come back. I can't think of what it is. Yeah. The rooms.
Okay, let's start with the rumen. What are the functions or purposes of the rumen? Fermentation. What else? What else does the rumen do? Mixes. What else? Absorbs. Specifically what? DFAs and electrolytes. How big is it? Garbage can, right? Looking at something like this. We'll see tomorrow. Or $5.95. So DFAs and electrolytes and not water. Increased surface area structure is the what? Papillae. Reticulum. Purposes or functions. What is the nickname I gave it? Director. What is the director? What is it direct? Feed is part of the contraction motion, part of the mixing. What else? What else is it direct? Sort of alluded to the feed, decides what stays, what goes. What else is it direct? What? Regurgitation or rumination. It directs. What else? What's the other thing that has to be managed in that forestomach? Gas, eructation. removal of that gas. If you want to write burping, that's fine. So absorbs what? VFAs and electrolytes. How big is it? About a football, American football. Structure that increases the surface area. The honeycomb pattern in there increases the surface area. Omasum. What does the omasum do? Absorption is the big function there, especially water. So that's a contrast between the other one. What else does it do? Helps sort what goes to the lower tract and what doesn't. Absorbs what? Water. VFAs and electrolytes again. VFAs and electrolytes, when absorption, are always paired together. Size. Soccer ball, football, somewhere in there. Surface area increase. The leaves, lamina. I failed pronunciation when I was a kid, sorry. Okay, abomasum, what's it do? Through stomach, so it's going to start digestion by the animal. So that's hydrochloric acid, that's enzymes, all are going to work together to do that. Absorbs? Well, not a lot, right? Certainly alcohol, right? But you guys are too young to know that, right? Except for Chloe. I think you're over 21, right? So you may have experienced that part of life, but all of you under 21, I'm sure, have not, right? Tim as well, lot of experience. Maybe not. Size? About 2 gallons. Structure that increases the surface area. Folds. Is this helpful? So all that stuff we talked about last time, it summarizes very easily into this table. Does everybody see that? So instead of studying all your lecture notes, now you just have one. So everybody got 100 on this, right? Okay, we'll make sure that gets recorded as such. Okay, last time we left off with the attributes of our ruminal fermentation. Did anybody think about that since they've been here? Yes, no. Did anybody think about that? This list and how would you summarize this in one sentence? Anybody think about it? We got a no back there. Anybody else? No. No. Okay. So how would we summarize this in one small phrase or sentence? What is being produced here by a cow or any other ruminant is the perfect environment to grow these bacteria. It's warm, it's wet. We do catering, brings in the new food. Garbage disposal gets rid of all the waste products. It's a perfect environment for the growth of these fermenters. And you'll get to experience that environment firsthand tomorrow. One of the keys to fermentation is a lack of oxygen. The whole system, the whole ruminant falls apart if there's too much oxygen in the rumen. That's not usually a problem as long as that fermentation is going. It's producing methane, producing CO2, and it displaces all of the oxygen out of the body. all the oxygen out of the body of the rumen. If we have oxygen there, what process can occur? Respiration. If respiration happens in the rumen, what happens to all the goodies in there? They go to CO2 and water. Is there anything left for the cow? Water is important, but CO2 you can't make a living on. So having that in an anaerobic environment is key to unlocking that NDF, but not allowing microbes to take everything. So let's talk about where everything occurs. So I'm going to start with the rumen and the reticulum. So reticulum is down here, rumen is out here. You've got the salivary glands out here. We got our esophagus. Then we're going to disarticulate. We've got the abomasum and omasum here. So this is our stylized digestive tract. These squiggly lines here are the small intestine. We have what's called the cecum here. This is equivalent to our appendix. Our appendix does nothing but causes trouble for us. I've had mine out. That was a very interesting day. And then there's the large intestine or colon in the back. And then we finish up with the rectum and the anus. So if we're looking at this, we've got a number of different processes that are happening along the way. So we got our big fermentation is going to be in this pregastric vat, right? Reticulorumen, the rumen reticulum. We're going to have fermentation there. That's going to account for about 90% of all our fermentation, the nutrition extracted from it. We don't talk about it much, but we will also get fermentation in the cecum. And then to a limited extent, the large intestine. The cecum will also, just like a horse, that hindgut fermentation is going to augment what the cow does. That's going to be the other 10% of our NDF fermentation is going to occur there. What we have in between those is digestion. So we start digestion here, D for digestion, and that's going to go all the way through to the large intestine. To a limited extent, you're going to have, starting here, this is going to be the small intestine. This is the big area of digestion, the important area of digestion. If we think about absorption, moving through, I guess I should mention there's a little bit of digestion in the mouth. Starch. We have enzymes that'll break apart starch in the mouth, even on the nose, which is kind of weird. I don't know why they'd need starch digested on the nose, but it's there. So we talked about absorption. What gets absorbed from the rumen and reticulum? BFA, and water. Move on to the OMA, BFA, and electrolytes. Sorry, I got excited. Move on to the OMA sum. We have the absorption of water, BFA, and electrolytes. Absorption from the abomasum, not much. At least not much that we're going to worry about in this class. Small intestine. Absorption, everything. We have water absorption. We have carbohydrate absorption. We got fat absorption. We got protein absorption. We've got minerals, vitamins, everything that we'll talk about in this class is absorbed in the small intestines. We get back to fermentation again. What's going to happen here? Where have we seen fermentation before? Front end. What gets absorbed there? BFAs and electrolytes. Then for the large intestine, dealing with a lot of water absorption or secretion, as the case may be. And we have a lot of mineral management, things being absorbed, things being secreted in the large intestine. Any questions on that diagram? So where's absorption occurring? Pretty much everywhere. At least that's an acceptable answer, except the abomasum. Maybe the salivary glands. Fermentation, rumen, reticulum, cecum, large intestine. Digestion, abomasum and small intestines, and there might be some in the large intestine. Any questions on any of that? So thinking about that fermentation a little bit more, how does the rumen fermentation compare to other fermentation systems? If we're thinking about the whiskey plants, anybody been to a whiskey maker and seen their large vats of stuff bubbling up and fermenting and all that? Anybody seen one of those on its tour? We got one. So that, or the silage fermentation, or beer, or any forms of alcohol, will have a lot less bacteria or microorganisms per milliliter. We're talking like 10 to the 5th. Does everybody know what it means when I say 10 to the 5th? 1 with 5 zeros, so 100,000 bacteria in a milliliter. When we get into our ruminants, we're looking at maybe five orders of magnitude, 10 to the 12th, 10 to the 10th. So for every one bacteria that we might find in a whiskey or a beer or a fermentation up the dairy, you're going to have 10,000 to 100,000 more for each one. So you're multiplying the concentration of bacteria by 100,000. Why does that happen? 10,000, 100,000. Why does that happen? I just told you. The best environment to grow bacteria leads to more bacteria per unit of volume. That near perfect environment promotes that large concentration in a small volume. Everybody here know what symbiosis is? We got a couple heads saying yes. Anybody not know what it is? What did you learn about symbiosis? They work together. What's the classic one they teach you in biology? The lichen is algae and fungi stuck together, right? They're working together. One dissolves the rock, the other generates glucose, and they both live happily together. We got symbiosis between, if we take the microbes in the rumen as a whole, a symbiotic relationship between them and their cow host. So both parties benefit. That's different from parasitism, where one party benefits, the other is damaged. Forget what the one where one benefits and the other has no effect. I forget what that one's called. So we're thinking about symbiosis. What do the cows gain and what do the microbes gain from this relationship? So symbiosis is the relationship between two species where both parties benefit. So what do the ruminants provide the microbes in that perfect growth environment? They provide a place for the microbes to live. So there's a school of thought, if you read some of the more far out biology texts, the only reason we exist is because microbes needed to move from one place to another. They needed they needed basically a school bus to move them from one spot to another. It's an interesting theory. Again, we have to remember we're not at the top of the food chain. So place to live, transport. Microbes have very short legs. They do not move very far. The cows can cover more distance in one step than that microbe could cover in its whole life. So taking it to new places, taking it to new resources is important. Garbage removal. At the end of the day, the mixed fermentation is going to produce VFAs, which is a waste product to the microbes. Volatile fatty acids. It's going to produce gases, which are a waste product. They need to go somewhere. And they also need to get rid of that used or dyed fermented feed. They need to get rid of the spent feed. So the ruminants will do that for the microbes. They're going to be providing nutrients by constantly consuming new diet, having things come in. So putting that together, and they'll provide a neutral environment, something close to pH 7 that allows the microbes to grow and thrive. As we move away from that pH 7, the microbes don't do very well. So part of the garbage disposal is removing the acids that are created. That's going to keep the environment neutral. It also provides sodium bicarb from the salivary glands. Does anybody here know how many gallons a day a lactating dairy cow will produce of spit? 60 gallons. So 55-gallon drum. If you drain the salivary glands, which wouldn't make the cow very happy, that would be filled every day by a lactating dairy cow. Anybody here watch wrestlers trying to make weight spitting into a cup? It's going to take a whole long time for a human to produce that much. But a cow does 60 gallons every day. That's part of that neutral environment. We get into specifics. What do the microbes provide the ruminant? 4 broad benefits. The digestion of cellulose and hemicellulose. So breaking up that NDF, unlocking it, turning it into VFAs. Those VFAs are then accessible to the cow. The NDF is not. The VFAs, the volatile fatty acids, are. As the microbes grow and digest that NDF, they are going to live, expand, and multiply. microbes are about 60% protein. As they live and grow and multiply and raise families, they are going to generate from very simple inputs a reasonably high quality protein, not as good as eggs or milk, but a reasonably good protein that the cow can live on. Our cows are living on microbes that are produced in the rumen. The microbes are also going to produce vitamins. They're going to produce all the Bs. So B1 through B, I think 12 vitamins. We'll talk about those at the end of the semester. They'll produce vitamin C, but that's really not here or there to a cow. Does anybody know why that is? Cows produce their own vitamin C. But there will be vitamin C associated with those microbes. So they'll use it, maybe. We don't produce our own vitamin C, and that's why we get into trouble. It also produces vitamin K. Does anybody here from their Quiz Bowl days know what vitamin K does? What? Nope. K stands for clot. C-L-O-T. But it's the German spelling, not the English spelling. So kindergarten, or my grandfather, Carl with a K, not a C. He's very adamant about that. And given enough time, the microbes can detoxify almost anything. It's a race between how long it takes them to adapt and detoxify versus how fast that'll kill a cow. But if you wean it in slowly, cows don't have nearly the problem and ruminants don't have nearly the problem that some of our simple stomached or equine have with the toxic compounds they consume. So the digestion of hemicellulose and cellulose by the microbes. We're gonna, and I'll slip back and forth on this, and I apologize. It's really the fermentation. It's microbial digestion, which is called fermentation. So the microbes will ferment that cellulose and cellulose, cut it up into pieces. We talked about those big cylinders of cellulose, taking all those things, chopping it up into real tiny pieces. So cellulase is the enzyme that breaks apart cellulose. When we see ASE, that usually denotes an enzyme that breaks apart whatever the front part is. So cellulose broken apart by cellulase. Lactase breaks apart lactose. Mannose breaks apart mannose. So cellulases are all from microbial origin, either bacteria, fungi, or protozoa. We don't have those things in our body except where the microbes produce them in our hindgut. So without microbes, ruminants would not be able to use the forage crops that we feed them, the pasture, the hay, the silage. They would not be able to make an efficient use of it. Again, we're looking at a species that tries to break things apart, tries to rip things apart to an extent digestive strategy as opposed to a passage digestive strategy. So we can think about this fermentation or digestion as the microbes unlock the carbon and energy in the cell wall or the NDF and make it available to the ruminant, to the animal. What are those VFAs? If you're looking in the rumen, if you measure all the VFAs there, 95 or better % are going to be one of these three. So you have acetic acid or acetate. I'll probably use those interchangeably. That is a 2-carbon unit. So how many carbons are in glucose? 6. So we're chopping up that glucose in the cellulose into 2 carbon units. That's going to be acetate. Propionate, we're going to split that glucose in half and have carbon unit, 3 carbon unit. Propionate or propionic acid is the highest, second highest concentration in the rumen fluid. And then move it up to the 4 carbon unit where we're cutting off a piece and we're left with 4 carbon units. Butyric acid or butyrate is the third highest concentration in the rumen fluid. Over here, these are the organic formulas for those acids. So you have carbon with 3 hydrogens attached to it, connected to a carbon, which has an acid unit on the end of it. 2 carbon units attached to a carbon with an acid unit on it. 1, 2, 3, plus a 4th carbon with that acid unit on the end. If we take a look at, I believe the next slide shows what the difference is when we're thinking about the names. Most people go back and forth, not thinking about what they're really talking about, but I want to make sure you're introduced to it. So each letter represents a different atom. So H is for hydrogen, carbon, C is for carbons, O's are for oxygen. The straight lines between them are the bonds that hold those atoms in that particular configuration. So the difference between an acid and a tate is what? So we lose that hydrogen to the solution. It goes into solution. It's a hydrogen ion. It's an acid. So if it's attached, we still call that the acid form. If we've lost it, we're going to do it the ate form on the end. So this is meant here, here, and here to represent if we lose that positively charged hydrogen, what's remaining, this row all here has a negative charge to that. That's important when we start to think about absorption and how things move through the body and whether or not they're toxic as we go through. I'll probably use the acid form and the ate form interchangeably. I don't necessarily mean to. Any questions on that? So microbes to ruminants. Continuing on with the cellulose. They're breaking it apart. The second provision is high quality protein. They're going to take a cut of energy from that NDF, from that cell wall, and they're going to use it to live. In so doing, they're going to take carbon units, they're going to take energy, and one of the things they're going to do is build that reasonably high quality protein. If we think about our cows, our ruminants all across a range of types, about 50 to 80% of the absorbed nitrogen, and is for nitrogen, that's the key defining element in a protein, is going to be from microbial sources. So if we think about a heifer growing up, probably most of the nitrogen is going to be from a microbial source. If we're thinking about a high producing mid-lactation dairy cow, about half of the protein is going to come from microbial sources. Where's the other source of protein? Anybody want to guess? The unfermented feed, whatever leaves the rumen unfermented, going to lower tract, that's what the animal has to work with. What we're trying to do with our cows is trying to increase the microbial efficiency to provide more microbial protein. So what we mean by microbial efficiency is we want them to grow rapidly and be pushed down the lower tract pretty quickly. We don't want microbes to basically cannibalize each other, and that's where we lose some efficiency. If we're looking at our dairy cows, we're looking at 3 kilograms of microbial protein produced per day. So does anybody know what that is in pounds? 6.6, 6 to 7 pounds of microbial protein every day. If we can make that happen efficiently, if we can make that happen productively, we can take advantage of what the cow does. Let her do the work instead of us buying expensive protein. If she can produce it herself, that lowers the cost of our operation. Let her do what she can do and let her do what she does best. And hopefully moving forward, we can establish a system to do that. Part of having a system that does that is measuring your dry matters on a regular basis. When we think about the microbial protein, we're going to have a reasonably what's called high biological value protein source. We have very high biological value would be milk or eggs. That profile of amino acids, the profile of protein almost perfectly matches the need of that animal that's growing. We step down to that's like 96, 98% biological value. The microbial proteins somewhere in the 80s. We get down to plant proteins, we're in the 40 to 60 range of biological value on a percentage basis. That means about half of the amino acids don't need to be there. They are not necessary. It's inefficient. It's wasteful. If you're thinking about an egg, right? What do we know about an egg? It is high protein, but what's the purpose of an egg? Protection, yes. Every building block, every piece of energy that you need to build a chicken is inside that egg. So we want it to be as efficient and perfect as we can be. It still amazes me that somehow all that stuff gets rearranged and something living pops out. It's all in there. We can't import things. We can't export things. It's all got to be in there. So we'll start there next time. Did everybody sign the attendance sheet? Make sure you check off your name. If you got a question, drop it off. Over there, sorry. Can you pass that up, please? Thank you.
Dr. Mooney,
Yes,
we changed that Friday.
I think so. Friday at 11. I'll confirm that at the beginning of class on Monday.
All right, thanks so much.
You're welcome.